Hi guys, welcome to the fourth episode of Coincunews Podcast. I'm Cass. I will be the host for today's show. So in today's episode, we will focus in, interview with Dom, our guest today, on the need for a decentralized wealth and the problems associated with the Web2's technology structure in light of the aforementioned news. So, welcome Dom. Dom. So may I call you Dom, or do you want to?
Of course, yeah.
Okay, so this is Dominic Williams, our guest for today. So he's the founder of Dfinity Foundation. So welcome to the show.
Thank you for having me, Cass.
Okay, so it's really nice to see you here. So how are you?
I'm good. We're talking. I'm in Zurich currently, in Switzerland, which is where our biggest research center currently is.
Oh, so are you based in Switzerland?
I was in Palo Alto for 10 years, which is Silicon Valley, California. Mm-hmm. And then I relocated to Switzerland in June 21. Mm-hmm. And there are a bunch of reasons. Previously, before COVID, I was flying back and forth from California to Zurich all the time. And then, of course, COVID made travel pretty much impossible. So I hadn't spent much time with the Swiss team in person, so I thought it was a good time to do it. And, we've actually grown here very fast. The Dfinity Foundation is Switzerland's biggest employer of ex-Googlers. And there are a bunch of reasons for that. One is that Zurich is actually the location of Google's biggest base outside Mountain View in California, and it's where they do a lot of their research. So we hire a lot of smart people from Google, also from IBM and other places in Zurich. And of course, Zurich has got Zurich ETH, which is an absolutely fantastic technical college, on a par with Cambridge, Stanford, MIT, that kind of thing.
Okay, that's very impressive. So before we start, maybe you can do a little bit introduce about yourself and also a little bit background of Dfinity Foundation.
Well, I'm what you'd call an engineering entrepreneur. So I like building things, and I've got a strong computer science background. I've been building things for quite a long time now. Just before getting into crypto, last thing I built was an MMO, massively multiplayer online game that I grew to some millions of users. It's quite interesting sort of venture technically, because I had to scale out this game server architecture and store enormous amounts of data as well, and some of that experience informed my thinking when I got into blockchain full-time at the end of 2013. Spent 2014 trying to repurpose traditional Byzantine fault-tolerant consensus math for the blockchain settings. I was the first person to do that and try and design a blockchain that could process hundreds of thousands of transactions a second. And I worked on this blockchain in 2014 called Pebble. Never launched it because I heard this idea for a world computer. Mm-hmm. And as soon as I heard the words world computer, I thought, look, that's just got to exist, because people were realizing at this stage it was, Ethereum was in the works. I was part of the early Ethereum community, and we were realizing for the first time that a blockchain can host more than just tokens. It can also host code and data. So my thinking was, well, what if you could build a blockchain that could host all of humanity's code and data, and that blockchain would be a world computer that would one day host the vast majority of humanity's online systems and online services. And because you'd build these online systems and services using smart contracts, they'd be tamper-proof. You wouldn't need firewalls to protect them, and the sort of special properties of smart contracts would make it possible to reimagine and reinvent online services in Web3 form, although we weren't using the word Web3 back in, say, 2015. So I sort of set out on a journey and I pivoted my research a bit. And for most of 2015, I was working on this sort of world computer concept. I think the intention back then was that the research, we were already using the word Dfinity, which is a shortening of decentralized infinity, right? And we're already using Dfinity as a moniker for the project, and the intention was that this research would be used to create an Ethereum 2 or an Ethereum 3. But there was a sort of fork in the road, and in 2016, Dfinity became its own project. It was incubated by a sort of crypto venture studio in Palo Alto, which I was a co-founder of alongside a guy called Tom Ding. Eventually, the Dfinity Foundation was created in Switzerland in October 2016. It ran an ICO, one of the first ICOs, in February 2017. Raised more money in 2018, and the Dfinity Foundation, built what is certainly blockchain's largest R&D operation, and it's continued growing. We don't really employ marketeers and communications people and business development people. It's really the Dfinity Foundation is really currently, at least, just a giant R&D shop, and we're almost 300 people strong worldwide. We have probably the biggest team of senior cryptographers in tech. So, we have a bigger team of senior cryptographers than you'll find at, places like Google, for example. And that, among other things, has enabled us to sort of reimagine blockchain architecture and develop new forms of cryptography that really made it possible to create a blockchain that runs much, much quicker, that scales out, where smart contracts, the code that you host on the blockchain, can even serve web experiences. They can process HTTP requests, and where computation and data is processed and stored with, efficiency that's many orders of magnitude superior to the most efficient traditional blockchains. So, for example, I think in the last calculation, the internet computer is 23,000 times more efficient than Solana. So these are not small differences. It's the only blockchain in the world that can serve web experiences directly to end users. It's the only blockchain in the world where you can actually build services on the blockchain, which is very different. When you hear built on Solana, built on Avalanche, built on Near, built on Ethereum, it doesn't mean built on those blockchains. It doesn't even slightly mean that, right? What it means is that the service is built on Amazon Web Services, right? Big tech's cloud computing service, right? And when you're interacting with their websites, that website's coming off Amazon Web Services. All the data and processing is done in Amazon Web Services, and just occasionally, you'll using like a MetaMask wallet or something, you'll interact with the blockchain to purchase a token or an NFT or something like that. So that's really the old way of doing things. Albeit, of course, the Dfinity Foundation and the Internet Computer Project is one of the oldest in crypto. But since the advent of Internet Computer Mainnet, you can actually build real Web3 services that run 100% from the blockchain and don't involve traditional IT at all. No cloud computing services. And for example, there's a service called OpenChat, which is a messaging service where that serves its user experience into browsers on mobile or on desktop. That runs entirely on chain, and smart contracts are actually processing individual chat messages and processing and storing everything from chat, text messages to photos to videos on the blockchain itself. So that's a complete game changer, and it's made possible by radical new cryptography created by the world's largest sort of team of eminent cryptographers.
Oh wow, that's just like a really massive information that I have never heard about it, but it's really amazing. Like it's like really make me like stunning, like how blockchain could be, be able to like work fully 100% like that. And yeah, I mean, maybe like you can talk more about like how could blockchain could be the game changer in the future, like just in your opinion.
Well, I mean, so first of all, I think you've got to distinguish between, a lot of traditional blockchains and the internet computer. They're very different beasts. And I don't, aside from the developers who are building on the internet computer, and there's a few thousand of them, most people aren't aware of these differences. Mm-hmm. And blockchain really is an interesting industry because if you do a survey, you'll find that 99.9% of people have no clue about the practical realities. A lot of people just, store tokens on exchanges and see it almost like a casino. Which project has momentum, and they invest in hype and things like that. So if you do a survey, of people, and you say things like, okay, what does it mean when someone says built on Solana? Most people will tell you, and we've done surveys, like, 9 out of 10 people plus will tell you, oh, it means that Solana's acting as an end-to-end blockchain, an end-to-end decentralized platform, yeah. And when you tell them, no, that's not, when you tell them that's not how it works, people are building these Web3 services on the cloud, and they're just keeping a few tokens and NFTs on Solana. Yeah. Like people's minds are blown because they've been sold this vision of blockchain, which is very different to what they've been investing in, if you like. And people are often very shocked when they find out that this project with all this razzmatazz and all this apparent positive energy around it actually is just this sort of simple thing that stores some tokens and NFTs. Similarly, I mean, people are still coming to grips with the idea that most NFT content is stored on Amazon Web Services S3, right? Mm-hmm. And similarly, I think, you hear a lot of stuff like blockchain the blockchain industry really represents and markets tokens to people. Yeah. And as such, like crypto media doesn't give people the information. So, you'll hear things like Solana processes the most transactions a day, and that's why it has all of these outages. Well, look, that's complete nonsense, right? I mean, the internet computer currently is processing more than 500 million transactions a day because people are running social media on it, on the blockchain. And since mainnet launch May 2021, it's never had a second of downtime, right? So I think that's the first thing to understand, that all things in blockchain are not equal, and a lot of projects really just have kind of poor technology and are just token marketing enterprises. And they sell the token, they get money, and they use that money to pay developers to build on their platforms. Now, of course, even this language is deliberately misleading, to build on their platform, or to build on Solana, build an app. It doesn't mean that. It doesn't mean that. It means build on Amazon Web Services and then just keep some tokens on those blockchains. So I think, but the thing is, then you create this hype machine where you sell the tokens, get the money, pay developers to build, in inverted commas, on your platform, which really means Amazon Web Services. So those things, you've got to put those things, when I'm talking about blockchain, I'm really talking about the internet computer, because this is the network that encompasses all the innovation in blockchain today. So Dfinity Foundation, has been going for many, many years. Dfinity research began in 2015. Ethereum 2, this might be surprising to some listeners, Ethereum 2 is really an old Dfinity design from early 2015. This idea that you create a random beacon within the network and it selects committees that then produce a block, and then the members of the committee witness it and so on. That's an old Dfinity's design from early 2015. And in fact, with respect to BLS, which is the cryptography used, we've been using that from the beginning. Ben Lin, who's the L from BLS, actually works at Dfinity. And it was many years actually before Vitalik Buterin would even accept that BLS was safe cryptography. Albeit now, of course, Ethereum 2 relies entirely on BLS. So, Dfinity is really the sort of fountain of innovation in this space. Many things that people are wanting to use now came from Dfinity, even things like BLS cryptography. One of the inventors works at Dfinity. WebAssembly, which is the sort of next generation virtual machine everybody wants to use. Again, Andreas Rosberg, co-inventor of that, early Dfinity guy, and so on. So what Dfinity did is completely reimagine blockchain architecture, very, very ruthlessly and methodically, to answer the question, how can a blockchain play the role of a world computer, right? How can a blockchain play the role of a world computer? And as it turns out, you have to make a lot of changes. And in the end, that involves the development of novel cryptography and assemblies of novel cryptography and distributed computing protocol math. And we call that chain key crypto. So the good news is, that's running today and it's proven in production. And if you want to build a service, like, for example, a SocialFi service, a GameFi service, or even a DeFi service where, the front end, everything runs end to end on the blockchain, you can do it today on the internet computer. And you can also do other things too, because just recently it's gaining new capabilities. One of these is called chain key transactions. So on the internet computer, you can write smart contracts that can create transactions that run on other blockchains. So for example, smart contracts on the internet computer can directly manipulate or can create Bitcoin addresses and send and receive Bitcoin, but there's no bridge involved. They're doing it directly. So you can create native Bitcoin DeFi on the internet computer. You can create Web3 services on the internet computer that involve Bitcoin. But when the Bitcoin is sent and received, it moves on the Bitcoin blockchain. It's not wrapped Bitcoin created by an insecure bridge that could get hacked. You can create, for example, a decentralized front end for Ethereum. So you can create a front end for an Ethereum DeFi app that maybe does a lot of processing even on the blockchain, on the internet computer blockchain, which interacts with Ethereum. So recently we demonstrated a front end for Uniswap that runs on the internet computer, where you can initiate transactions using the fingerprint sensor on your laptop or your Face ID on your phone with something called internet identity. On the internet computer, you can make calls out from the blockchain using something called HTTP out calls and bring in data without oracles. So there's a lot of very transformative stuff going on. But if you ask me, what is the really big picture here in the short term, it's that people can create Web3 services that are fully decentralized. And because they're fully decentralized, in the sense that they're built entirely from smart contracts on the blockchain. Smart contracts are processing HTTP and serving web. Smart contracts are, storing all the data involved. So if you build a chat service on the blockchain on the internet computer, those smart contracts are going to process every single chat message users send, every emoji, every image, every video, and store it there. Because you can do that, you can now place that service under the control of a DAO. A decentralized autonomous organization, because a DAO is able to control other smart contracts. A DAO cannot control, systems and services running on Amazon Web Services, right? Yeah. That can only be controlled by a person who's put a credit card into the Amazon Web Services website, right? A DAO can control other can configure and update other smart contracts if you so design it, and that means you can create a service, a Web3 service that really is decentralized, does run entirely on the blockchain, and you can place it under the control of a community DAO, okay? And that's going to be very important because Web3 really is all about ownership, and end users of services need to take significant ownership in the services that they use, and they're going to be incentivized. So for example, once you've got a Web3 service, say a social media or SocialFi Web3 service running on the internet computer controlled by a DAO, well, that DAO can airdrop governance tokens to users who perform useful roles. So users that refer other users, users that are advocates for the Web3 service, you can give them governance tokens, make them pod owners of this service, right? And that will incentivize them and create viral growth. You can airdrop governance tokens to users that help with things like content moderation. And this is the future of Web3, making users owners and making them part of the team. And that's what's going to drive viral growth. And that's how Web3 services eventually are going to overcome Web2 services. No one's ever going to build a vanilla Web3 service that, say, a vanilla social network that somehow supplants Facebook. If you want to create a Web3 social network that supplants Facebook, you're going to need to use the power of tokens. It means you're going to need to make the users of your social network owners and part of the team. You're going to need to get users advocating for that social network, to get users participating in things like content moderation, and create viral growth and network effects of the kind that Web 2 can't easily match. That's the future of Web 3.
Okay, that's really interesting. Like talking to you, that I have learned like a lot of things about like blockchain in general. But yeah, I mean, like so far that our audience also like want to know more, like in-depth research more about like blockchain, because so far right now that when people like mention about blockchain, all they can think of is like crypto. So yeah, so I mean, in today's podcast, like I've learned a lot, and of course like our audience also learned a lot. So you will mention about internet computers. So I have read some of your document. So for those people who don't have much information about like ICP, so maybe could you like explain for us like introly and how your company like believe that it will be the framework for the internet's future?
Well, so Dfinity actually is a foundation, not a company, and it's a not for profit, and that's, I think, very important because really a world computer blockchain is extending the internet, right? So and the internet is a global public network that's completely permissionless, and that has generated over the last three decades an enormous amount of innovation and social freedoms and economic growth. And the reason the internet did that is pretty simple. Like say for example, back in the day, let's say you built a website, Kaz, and I built a website, and they were competing, right? So we both built competing websites on the internet. I couldn't phone up the owner of the internet and say, hey, if you slow down Kaz's website, I'll give you some stock in my company.
Okay.
Right?
Right.
So the internet created a kind of free marketplace where everybody could connect, and that was its power. And it's probably before your time, but in the 1990s there was a lot of debate. Big corporations were saying the internet is uncontrolled, unregulated, wild. It's much better if we create walled gardens, like America Online or CompuServe, and Microsoft wanted to create this thing called the information superhighway. And the idea was that big corporations would be the gatekeepers of these networks and decide what content could be, available there. i.e. they wanted to create walled gardens. Now, we all know how that went. In the end, everybody preferred the open internet. And today we've got an analogous situation with the tech platforms we build on. Today, people are forced to build on, big tech's closed proprietary infrastructure, Amazon Web Services, Google Cloud, Microsoft Azure, and oftentimes, on things like Facebook, which also can behave as a platform. But it's very dangerous, Look, back in 2021, there was a sort of Trumpite social media website called Parler. Now, may not agree with Trump's make America great again politics, but I don't, but I certainly don't agree that Amazon Web Services switched Parler off because Jeff Bezos didn't like their politics. So that's an example of being deplatformed. Another example would be Zynga. Zynga, in the early days of Facebook, created this social media game called Farmville. and a Facebook game called Farmville, and grew to well over 100 million users. It was very successful. And Zynga, the company behind Farmville, did an IPO, went public, and it was worth many billions of dollars. And then Facebook just decided one day to change the rules, and Farmville suddenly became less viable as a game, stopped accruing users and so on. And Zynga's stock dropped 80%.
Wow.
Right? So that's another example of being deplatformed. And so, in the end, we build on the closed proprietary infrastructure of these giant big tech monopolistic corporations at our peril. And that's just one of the reasons. There are many other reasons why I think people will want to build on the internet, not build on closed proprietary infrastructure. So the internet computer is designed to extend the internet so you can build on the internet. It's designed to provide a world computer. And the idea is that in the future, we're going to build all of the world's systems, enterprise systems, and all of the world's services, things like social media, or SaaS services like Salesforce, on the internet itself rather than on closed proprietary infrastructure. And the cool thing is with services that you can do completely new things with smart contracts when you're building with smart contract software rather than, the kind of code you run on Amazon Web Services. So smart contract, obviously, are tamper-proof, first of all, so you don't need a firewall to protect them. So for example, there are thousands of services now running on the internet computer, and none of them are protected by a firewall, right? Because they've been built with smart contracts, and they all run 100% on the internet computer rather than using traditional IT of the kind you find in Amazon Web Services, which is insecure. So the first thing is they're secure by default. You don't need firewalls or anything like that. The second thing is, on the blockchain, you can process value as data in the form of tokens. You can also do similar things with identity and other related entities. So in addition to that, your code can be autonomous. And that's very important. Autonomy means that your code, your software, can run without having a human owner or a traditional organization behind it.
Okay.
And this is very important because it means that you can create, for example, a DAO, a decentralized autonomous organization. And that DAO can vote on proposals, for example, to update a service or configure a service like a social media service, according to the wishes of its community. Maybe you've got thousands of people who hold governance tokens who can vote. And there's no one person or organization or any agency, no regulator who can turn this DAO off. It's a digital, automated, autonomous democracy that runs in cypherspace or cyberspace, whatever you want to call it. It's extra-national, doesn't live in a particular jurisdiction. The participants in that DAO can be all over the world, and it's unstoppable. And so you can now, clearly express through algorithms the wishes of a community that's distributed all over the world, with respect to a range of things. It could be just a fund. How do you want to invest some funds? Or it could be, how do you want to update and configure this, Web3 social media service, right? And basically by fully decentralizing a Web3 service, running it entirely on a blockchain under the control of a DAO, you're basically running the service like in the mode of a protocol, right? And if you run a service in the mode of a protocol, you can now use advanced tokenization strategies. So for example, let's say you've got a Web3 social media service, you can start airdropping governance tokens from the DAO to users that refer other users to drive viral growth, or you can start airdropping governance tokens to users that help with tasks like moderation. And that's going to be the secret to how Web3 services overcome Web2 services. And you can only do this if you can build 100% on the blockchain. And
There's a lot of information over there. So far that from what I have do my own research about Web3, so I'm really fascinating about like how Web3 is gonna be in the future. Since the Web3 will be so all the data will be saved in different blocks, right? So is it like a problem for it to, you know, like during the connection, the time of the connection, you know, like the loading time, is it gonna be like slowed down because the different block is storing a lot of data and is gonna affect, like make a really big impact on the loading time?
Well, the data isn't stored in the blocks, first of all. So in a blockchain, the blocks just store transactions. And you play the transactions in sequence to create the state. The state is like the data, you know, a bit like the data in a database, but on a blockchain, it's the data associated with smart contracts and the ledger of token balances, right? And you create this state by replaying the smart contracts in the blocks. So, for example, you know, Ethereum is a sort of early, kind of very simple manifestation of this model. And you know, when you create an Ethereum node, it downloads all the past blocks and runs each transaction sequentially in order to build the current state, i.e. the current ledgers of balances and you know, the data associated with smart contracts generally. And so when you interact with Ethereum, you know, you're not interacting with the blocks, you're interacting with that state that's been created by playing the transactions in the blocks. So the internet computer works similarly, except that it doesn't keep old blocks. It doesn't need to because of the cryptography it uses. So, you know, internally, it's composed actually of lots of things called subnet blockchains. No relationship whatsoever to avalanche subnets, which are really something different, really just standalone blockchains. Internet computer subnets are invisible. So when you build one on the internet computer, it provides a single blockchain, a single seamless, you know, blockchain environment. But beneath that, the capacity is coming from blockchain subnets. And clever cryptography combines these blockchain subnets into a single blockchain environment. But those blockchain subnets, or subnet blockchains, as you want to call them, of course, you know, agreeing upon blocks of transactions, and they're running those transactions to create the current state. So far, similarly to Ethereum, the difference is that they don't need to keep old blocks because of the cryptography used. And when new nodes come and join those subnet blockchains, they literally just sync state, and they can be sure it's the correct state because of the cryptography. So, you know, in that sense, when you're interacting with smart contracts on the internet computer, you're interacting with code that's running against state. You know, the blocks of transactions are really just used to agree a sequence of transactions amongst all the nodes in a subnet. And you know, the guarantee is that all the nodes in the subnet will apply the same sequence of transactions and therefore, you know, create the same state. That's how all blockchains work. Speed, you know, the speed of these things, look, it's a difficult topic, but you know, internet computer has two kinds of transaction. One is called an update call, and that makes changes to that state, and they'll generally process those kind of transactions in 1 to 2 seconds,
Right.
and normally closer to 1 second. And then you have something called query call transactions, which don't persist changes to state, and they're pre-finalized. So they're things like, you know, HTTP calls, like, you know, if a web browser requests index.html, the CSS file, the JavaScript, some images, that kind of thing, those actually are returned as query call transactions, and they're pre-finalized and they're signed ahead of time. And the browser, actually, your web browser, when you're interacting with a Web3 service running from the internet computer, your web browser has a hidden bit of software installed called Service Worker, and it's verifying the signature on all this content coming from the blockchain to make sure it's not been tampered with. All that's happening transparently, so you're getting a secure end-to-end service. But those query call transactions, which are pre-finalized, I mean, they're served in milliseconds, and it's getting faster all the time. And again, that's unique to the internet computer, and that's one of the ways it's able to do what it does. And as I mentioned, today the internet computer is processing more than 500 million transactions a day. And the nearest equivalent blockchain is Solana, and it's doing 30 million transactions a day. So that gives you an idea of quite how far the internet computer's come. But we think next year it's going to go well beyond 1 billion transactions a day.
Okay, so then what are the main challenges that bring the blockchain to become the default platform for business model at the moment?
Well, I mean, I think the internet computer already would provide a great enterprise platform. But, the thing with the enterprise market is adoption is slow. And if you want to push it, you've got to spend a lot of money and time doing business development, which is very expensive. And, results come slowly. So what we're more interested for now in helping entrepreneurs and developers who want to build Web3 and DeFi and things like that, particularly Web3 services. Because in the end, when enterprise looks at the internet computer as a platform, if they see, for example, a service like OpenChat, that is processing the real-time chat messages securely, right, without firewalls, right, of 100,000, or soon I think it's going to grow rapidly, many hundreds of thousands or millions, or maybe one day hundreds of millions of users. Well, those same enterprises are going to think, hang on, how many people have I got in this company? Maybe I got 1,000, 10,000. If you're a really big corporation, 150,000 or something. And they're going to think to themselves, well, if these entrepreneurs can build Web3 services that serve millions and millions of people using the internet computer, and they don't need firewalls and they don't get hacked, and clearly I can use that same technology within the enterprise. So in a way, our strategy is just to lean into Web3 and allow the achievements of Web3 developers and what they build, right, to advertise the internet computer as a platform to enterprise. So we're very interested in, our objective is something called blockchain singularity. Blockchain singularity refers to a time when the vast majority of systems and services run entirely from a blockchain. And that's what we want to make happen. But obviously, as part of that, we want enterprises to re-engineer all our existing systems on cloud so they're running on the internet computer. But that's going to take decades, But what will happen much more quickly is, nimble young entrepreneurs and developers will come and build their dreams on the internet computer and, construct a new Web3 internet ecosystem. That'll happen much, much quicker. It's already happened.
Yeah, I also once you mentioned about the blockchain singularity, so I already checked that in the document, on the website, and it's require huge resources, and it's really a challenges for you to scale it and make the internet computer blockchain come true, right? Okay, so. Before we end the podcast, I want to ask you a little bit about the upcoming plan of Dfinity. So what you guys gonna do next, and anything that you guys want to share to the audience for them to know more about internet blockchain.
Yeah, I mean, I think going forward we're going to get better at communications and marketing. I think historically, the Dfinity Foundation has just been an R&D shop. And we've got this most incredible team, the strongest team of cryptographers in all of tech, but also lots of other brilliant people, huge, team of computer science researchers and very senior engineers and so on. And we haven't always been able to communicate that. Blockchain's a very competitive space. You will never read about the internet computer in the crypto press. I mean, none of the mainstream crypto press has ever reported on the internet computer. There's a reason for that, and it's very confusing for people who don't understand how blockchain works. The reason is that there are a lot of vested interests in blockchain who have hundreds of millions of dollars to lose if people find out about the internet computer, because internet computer technology is so far in advance of some of the other blockchains I mentioned. They're very worried that if people find out about it, that the value of these blockchains decreases. And those people have a lot of money and they control blockchain media for the most part, like, the main publications. The consequence is that you just don't hear about the internet computer in the press. There's a kind of blockade that the vested interests don't want blockchain enthusiasts to find out about the internet computer. But anyone, if you're really interested, you should go to internetcomputer.org, and research. Have a look into it. Have a look at the history of the project, and get the facts for yourself. We also, we've been subject to a lot of dirty tricks, which might come as a surprise. So there's now, thankfully, there's some investigative journalists who have been looking into some of the crazy things that happened, especially last year, and reporting it on this site called Crypto Leaks. So, people are wanting to understand some of the attacks that Dfinity Foundation and the internet computer ecosystem have been subjected to should go to this website, cryptoleaks.info. And, I think for many people, it'll be a very eye-opening experience. Doing these two things, researching the internet computer, going to internetcomputer.org, and then when you ask the question, why if this blockchain is processing half a billion transactions a second, why if it's got the biggest R&D team in all of blockchain, why if it's got the biggest team of cryptographers in all of tech, why if it's one of the original blockchain projects from 2015, why do I never hear anything about it in the crypto media? Dig in, have a look what's there. You'll be amazed when you see the technology, amazed when you see the team working on it. Go to cryptoleaks.info if you want to understand, what we're up against in blockchain. In blockchain, nothing's as it seems, I'm afraid. A lot of people just exist to sell you, just work to sell you tokens, and oftentimes that's all they're doing. So I think, for listeners that are interested in this grand crypto project and the internet computer, and want to understand the power of a world computer and what is going to be possible, go and have a look at these websites.
Okay, I'm looking at it right now.
Oh yeah, Crypto Leaks is entertaining. Cryptoleaks.info. When I first saw this website, I couldn't believe my eyes.
Yeah, because what you have shared before is something that, like you said, I have never read before. And
you never read it. But Cass, here's an example. I mean, you do a survey, and this is an example. You ask people, what is the cost of storing one phone photo on the blockchain? Now, Solana is meant to be the most efficient blockchain. Currently, it costs you about $400 to store one phone photo on Solana. In practice, the technology won't even let you do it. It'll choke. But if you were going to do it in lots of tiny little pieces, you could upload a phone photo to Solana for $400. On the internet computer, it'll cost you about 1.6 cents a year. That's still too expensive, but it's a lot less. It's actually 23,000 times less. So, it's the same thing as when you ask people, what does it mean when someone says built on Solana, built on Avalanche, built on it? They don't realize that it's a kind of marketing, it's kind of false, misleading advertising, right? Because it's not really built on those things at all. It's built on Amazon Web Services, and the blockchain's just been used to keep a few tokens and NFTs. Built on the internet computer actually means built on the internet computer. The whole thing can run off the blockchain. All the data's there, all the computation's there. The smart contracts are serving the interactive web experience into the browser. And a lot of people find this just completely mind-blowing when you explain it, because that's not how it's represented in the media. And the other piece is, I think, why people find it so difficult is that the internet computer is literally shut out of blockchain media. There's a literal behind the scenes of blockade. And the reason is the owners of a lot of the writers are invested in these tokens. And then there's a sort of direction coming down from the owners, like, don't report on the internet computer. It's highly disruptive. Keep a lid on it. And as a consequence, imagine this: internet computer, one of the oldest projects in crypto, right? Started in 2015. Ethereum 2 is using an early Dfinity design from early 2015. Biggest R&D operation in crypto that's been running for years. The biggest team of cryptographers in all of tech, with these incredible groundbreaking features. And yet there's never been a single article in the mainstream crypto press that reports on a single one of these capabilities. And so it's no wonder that your average, crypto person hasn't heard of this, right? But it's by design. And, if people really want to understand the future of crypto, what the power of the technology and the potential of it really is, they should go and check out internetcomputer.org. And if they're feeling a bit angry when they read it, why haven't I heard about this? And they want to understand more, go to cryptoleaks.info, because that'll just blow your mind.
Yes. So after having a conversation with you, my mind is already blowing right now, and it continues to blowing, because these are those information that I've never seen before or heard before.
And you won't. And you'll never hear it. You'll never hear it on the press. And also, even on places like Reddit, there's a sort of there's a system. A lot of people don't realize that, the blockchain ecosystem is designed to sell you tokens. And what you see on social media isn't really a natural representation of even community sentiment. So if anyone talks about the internet computer on cryptocurrency Reddit, for example, or anything like that, it's immediately shouted down. But it's not by normal people. What your listeners need to understand is that in crypto, there are these armies. In China, you call it the water army, right? And these bots, human bots, and they're directed by these blockchain projects, and they're directed to troll projects like the internet computer, to give the impression there's something wrong with them, and then constantly say positive things about these projects that are really just rubbish. So it's difficult for people to really see what's going on in blockchain right now. It's a very tricky and corrupted industry, but the good news is there are people and there are organizations like the Dfinity Foundation that are not just trying to sell tokens. They're actually trying to develop real, game-changing, world-changing, socially impactful new technology. And very clearly, something like blockchain singularity can change the world for the better in numerous ways, and we're making it possible. And I'm actually moving in that direction right now with the internet computer.
After talking to you, I have learned so many things, and definitely I will check the two websites that you mentioned, and I will send it to our content team, and our research team as well, so that they can do some research, and we will definitely write some article about this. And
good, do so.
Yeah.
I hope you enjoy.
Yeah. It's, oh my gosh, I learned a lot of things today, and yeah, it's really great. And I believe that all of my audience also believe that they also learn a lot through this podcast. And thank you very much for joining today. So, do you have any, any words for Coincu Podcast audience that you want to share with us?
Just that, blockchain is really the future of the internet and the future of everything. In the end, everything's going to run on a blockchain. But you need to understand what those words mean. Run on a blockchain. It doesn't mean just keep a few tokens and NFTs on a blockchain. It means that everything, the entire future internet will run on a blockchain. All of the computation, all of the data, all of the web serving. And it's going to absolutely change the world. And there's huge opportunities for entrepreneurs and developers in Web3. But just make sure you're building on a real platform, not on just a token database.
Yes. I also like mistake of like build on Ethereum, build on Solana, and Avalanche. And
yeah, it's completely misleading, right? So, I mean, look, Ethereum I think's got a bright future. We plan to help extend Ethereum, so people are already building front ends for Ethereum DeFi on the internet computer, and also offloading computation and data that was previously onto the cloud onto the internet computer blockchain, so they can build fully decentralized services. And they're leaving the financial rails on Ethereum, because Ethereum can handle the financial rails, because on the internet computer you can write smart contract code that actually interacts directly with Ethereum without a bridge. So we think the internet computer is going to be used in lots of different ways, and there's a lot of potential. People should check it out and look what's being done. But certainly, you wouldn't want to build a social media service on Ethereum. That's ridiculous. I mean, it costs you. Check this out. I mean, if it costs you $400 to store a phone photo on Solana, it costs you about $60 to $70 million to store a phone photo on Ethereum. And I think a lot of people in blockchain aren't really familiar with this kind of gradient graph, like, $60-70 million to store a phone photo on Ethereum, $400 to store a phone photo on Solana, 1.6 cents to store a phone photo on the internet computer. Like, people just see these brands being bandied around and they've got no idea of the differences between the networks.
Right. So, I mean, there's a lot of information, and of course, this is like the new things to everyone in the crypto space so far. So once again, thank you very much for today's talk. It's really my honor to listen all of these information, and yes, thank you for managing your time today. It's really a pleasure to meet you.
Pleasure. Yeah, good meeting you too, Kaz.
Thank you. And
Thanks, bye.
yes, and that's it for today's podcast. Thank you guys for listening, and hope I can see you guys in the next week.